Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 3 from the May-June 2023 paper 5 variant 1. This is the statistics S1 paper from Cambridge 9709. And this question here is about permutations and combinations. So it says, find the number of different arrangements of the 8 letters in the word cocooned. Okay, so here you have 8 letters. And if you look at the repeats, you have C appearing twice and O appearing 3 times. And then you have NED. Okay, so that's like 5, 6, 7, 8 letters. All right, so now we've got to think about the different ways of arranging these letters. Well, we don't really have to draw this diagram for this, but I'm just going to do it anyway. Just give a bit of a background of this topic. So 1, 2, 3, 4, 5, 6, 7, 8. There's 8 spaces that are going to be filled up by these 8 letters, and we have to find the total number of different ways, different arrangements that we can have of these 8 letters. Okay, there's no restrictions as to how the letters should be written down. So out of these 8 letters, there's 8 ways of choosing the first letter. And then there's 7 ways of choosing the one after it, and followed by 6 ways of choosing the one after it, followed by 5 of the one after it. Now there's 4 letters left, and then there's 3 letters left, and there's 2 letters left, and there's 1 letter left. So this is 8 factorial. This is what this means. 8 times 7 times 6 times 5 times 4 and so on, all the way to 1. That's 8 factorial. However, there are some repeated letters, and those letters are identical to each other. So some of the arrangements will be actually different in one sense, but they will be identical in the sense that they will look the same. So when you have a C and a C next to each other, it could be switched. If you switch them around, it looks the same arrangement. If you have 3 O's next to each other, or you have O's in different places, those O's can be switched around and they will look like they're the same arrangement. So that's why we have to divide by, okay, what will get rid of the repeats, which is basically the number of times the repeats occur. So C appears 2 times, so you say 2 factorial, and then the O appears 3 times, that's 3 factorial. Okay, so this will give you your answer. So we can use a calculator to get the answer straight away. So here we have 8 factorial. Here's a factorial button here. Divided by 2 factorial. We don't even have to put the factorial actually, but we'll just do it anyway. Times 3 factorial. Why? We don't have to do it because the 2 factorial is 2 times 1, which is just 2 anyway. So that gives you 3,360 different arrangements. Okay, so there's the answer to part A. Okay, no restrictions. Now part B is a similar question, except here we have some conditions. Now the first letter is an O and the last letter is an N. So we have no choice with the first letter. It has to be an O. So you have 1, 2, 3, 4, 5, 6, 7, and the last letter has to be an N. So we have now 1, 2, 3, 4, 5, 6, 7. In fact, we have 1 too many. Okay, so you have 1, 2, 3, 4, 5, 6. Then we got the 2 at the front and the back. So there are 6 kind of like choices that we have in terms of letters that we can place in places. But the O and the N, they are fixed. One of the O's is fixed and one of the N's is fixed. So here, as I did before, we have C appearing twice, O appearing 3 times, then we have NED. And in this case, we have to fix one of the O's. So now there's 2 O's. And we have to fix one of the N's. So there's no other N's for us. Once we fix them in place, what we're left with is 1, 2, 3, 4, 5, 6 letters. 6 letters we can place in any of those 6 spaces. So similar to what we did up there, that's going to be 6 factorial. However, we have some repeats, which is C repeated twice and O repeated twice. So you divide by 2 factorial times 2 factorial, and that will give us the number of ways with this restriction that they gave us. So we can just go back to this, change that for a 2 here, and go up there and change that for a 6. That should give us the answer, 180 ways. Okay, so there's the answer for part B. Now for part C. Find the probability that a randomly chosen arrangement of the 8 letters in the word cocooned has all 3 O's together, given that the 2 C's are next to each other. So here we have a special type of phrase in probability, given that. And that's where the sample space has now changed from, all the possible arrangements that, without any restrictions, to the fact that the two C's are next to each other. So our sample space, so probability is the successful outcome, okay, which is all threes are together, okay, divided by the total number of possible outcomes. So if the questions just said, find the probability that the randomly chosen arrangement of the A letters in the word cocoon has all threes together, and this part wasn't there, then we'd have to find the probability of, we'd have to find the number of ways of having all threes together, okay, all threes next to each other, and then divided by the probability, the unrestricted probability of, all of the numbers arranged which we found in part A. But this is not that question. There's something else here. The question doesn't stop here. The question says, given that the two C's are next to each other. So our sample space, okay, becomes that the two C's are next to each other. So we have to find the probability that the three O's are next to each other, given that the two C's are next to each other. And a little illustration of that type of probability would be, if you have, for example, a Venn diagram, and you have the probability, you have A and B. So if I said, what's the probability of A? Okay, that would be whatever's in this circle divided by the whole sample space. But if I said, find the probability of A given B, now what happens is, this means the probability of this circle, okay, the number in this circle divided by the whole thing. But this becomes, the sample space now becomes the B. So we don't look at the whole thing, we only look at this circle, the one that comes after given. And we can only choose things that belong to B. So the probability of A given B is just this part of A over B. So the B is the sample space, and just that part of the A is going to be the part that goes here. So basically the probability of A given B is the probability of A intersection B over the probability of B. Okay, that's what this basically is. This is called conditional probability. Okay, so how do we relate this to the question that we have now? Is that the sample space is now the two C's being next to each other. Okay, so let's look at that first. The two C's being next to each other. So let's say we have 1, 2, 3, 4, 5, 6, 7, 8. Right? 1, 2, 3, 4, 5, 6, 7, 8. Remember, we have here two C's. We have, let me do it like this. So we have C times 2, O times 3, N, E, D. Okay, cocooned. Right, so the two C's being next to each other means that you've got a block. This block is fixed. And those C's are now gone from our system. And we have here basically we have 1, 2, 3, 4, 5, 6, 7. These C's can move along or within this group, but they must stick together. So it's like one block. So we have 7 different ways of arranging these. So 7 factorial. But then we have to think about the repeats. Now, we don't worry about the repeats of this because we have to multiply by 2 factorial because there's 2 of them, then divide by 2 factorial. Why? Because there are, if you switch those places, they will look the same. So we don't have to worry about this because they're identical. Right? However, for the O's, there are 3 O's that are going to go in these places, and they can be in different places, but they'll be O's, so the repeats will matter. Okay, so the repeats here, you have to divide by 3 factorial. And that will be the total number of ways of having the two C's next to each other. That's our sample space. Okay, so we can say 7 factorial. 7 factorial divided by 3 factorial. That gives us 840 ways. So that's our denominator. And then we've got to think about all 3 O's being together and the 2 C's being together as well. Okay, that's like the intersection between these two. I have to think about that. So I've got to think about the 3 O's being together and the 2 C's being together. So let me just do the same thing again. We've got the 2 C's, but then we also have 3 O's. 1, 2, 3. Okay, so this is one block, and this is another block. So we got 1, 2, 3, 4, 5, 6, 7, 8. So here we get the number of things that we have to arrange is 1, 2, 3, 4, 5. So you got 5 factorial. Okay, and you divide by the repeats. There's no repeats from these letters and these ones because they can switch amongst themselves. It's like the repeats cancel each other out. So you just got 5 factorial. Okay, now what's 5 factorial? So 5 factorial is equal to 120. So basically, the probability of getting the 3 O's next to each other, given that the 2 C's are next to each other, so the probability of having a block of O's, given that you have a block of C's together, is going to be 120 over 840. Okay, which is 1 over 7. 12 times 7 is 84. So there's the answer, 1 over 7. Okay, so that's the total number of ways of getting 2 C's as well as 3 O's next to each other. And that's given that the 2 C's are next to each other in the first place. Right, so this would be the answer, okay? It would be 120 over the total number of ways it was a probability, over 3,360, if you didn't have that given part. Okay, we could have also worked out the probability of this, and then the probability of that, and then divided those 2 probabilities, which would give us the same answer, because you'd have 840 over the total divided by 120 over the total. Okay, and then you would end up 120 over the total, so it would be 120 over 3360 divided by 840 over 3360, which would give us basically 120 over 840, which would give us the answer anyway. So we could do it by the probabilities, or we could do it by the number of ways, but in the end we end up with 1 over 7. So the important thing is to understand in this question the word or the phrase given that. Okay, so this becomes the denominator. 2 C's are next to each other, that's now your sample space. And the number of ways of getting the 3 O's together and the 2 C's together is the numerator. Divide them, you get the probability. Okay, and there's the answer to this question, which was, I think, the part of the question that the student who asked me to answer it had a problem with. I hope that was clear. Thank you for watching. Other questions from this paper can be found in the playlist that will appear in the top right of the screen at the end of this video. Other questions from the topic of permutations and combinations from S1 of Cambridge can be found in this playlist. You can subscribe to the channel by clicking on this link, and here the video will show you how to use my channel to find what you might be looking for. Thank you for watching, and see you soon.